Hi guys, in this video we are going to learn a question from instantaneous center of rotation. In the last video we have already seen what's instantaneous center of rotation. Also we have done a basic question from that. If you are new to this channel, don't forget to subscribe it. Also, if you haven't watched that video, please go through that because I have explained some techniques how to deal with instantaneous center of rotation and how to use that to find the velocity of a moving object or from any points of that moving object. So in this video we are going to have a little bit difficult question than previous one. However, in this question we are going to use instantaneous center of rotation method to find the answer. So I'm going to read the question now. I have given some data below. Please copy those. After that, I'm going to read that. Once you listen, just try it in your own. After that, watch the rest of the video and check your answer with mine. Okay, let's start. The slider crank mechanism shown in this figure has a crank radius OA of 50 millimeter. So this is slider crank mechanism. Also they have given this OA is 50 millimeter and a connecting rod AB 200 millimeter long. So I have marked here A and this is B. AB is equals to 200 millimeter. Also the crank rotates at a steady speed of 500 revolutions per minute anti-clockwise. Using the method of instantaneous center of rotation, find the velocity of the piston B and the angular velocity of the connecting rod for the configuration shown. So they have asked to find the velocity of the piston B, which means we need to find the velocity of this piston B. Also they have asked to find angular velocity of the connecting rod. So we need to find the velocity of this B. Also we need to find the angular velocity of this AB rod. So they have given that when the crank, so they have given the instant when the crank has turned through an angle of 30 measured from the position where the piston is furthest from the crank axis ODC position. So they have asked to find that those both things when the angle is 30. So that's the main point. Also find the velocity of the center of mass G of connecting rod. So they have mentioned this is the center of mass of this rod AB. So we need to find what's the velocity of this point. Also they have given AG is equal to 70 millimeter. So please pause the video and try it on your own, so it would be very much useful, but be careful. Try to do it using instantaneous center method. Hope you have done that. In the previous video I have already taught that when you are having a question from instantaneous center, the main thing is we need to know a velocity from any points, any 2 points. That's the main thing. We need to know the velocity of 2 points of that body. So in this case we need to find the velocity or the angular velocity of this AB, which means we need to find the instantaneous center of AB's rotation. From that we can find those things. So in this case we need to find the instantaneous center of this AB's rotation. But for that we already knew when we are calculating or finding the instantaneous center, we should know at least 2 velocities. So how we are going to find that? So that's the main question. The main thing is we don't need to know all the values of that, but here we need to know the directions as well as magnitude of one velocity. So that's the basic needs for using the instantaneous center of method. So in this case we can directly tell what's the velocity of A. Just consider that. If we consider this OA, we can directly tell as the OA is having a rotational motion or circular motion along this O axis. So if we consider this O axis is going to rotate this O. It's a crank. It's a rotation. So if we are considering like this, we can directly tell they have also given that omega OA. What's the omega angular velocity of this? From that we can directly tell what's the velocity of A. So that's the simple idea. So from that we can directly tell the velocity of A would be in this direction, which means 90 degrees from this. How I am getting this? We need to find the velocity, direction or magnitude of A, any 2 points of this rod. However, it's easy to find from A and B. So that's the idea. Why we are getting these, why we are choosing these 2 points is they have given the data to find these two only. That's the main thing. So when we are considering this, we can't directly calculate this A velocity or direction, but they have given some data over here. That's the simple thing is when we are considering this A point, it's connected to OA as well as AB, which means as this OA is having the rotational circular motion, we can directly tell OA would have the characteristic of that circular motion also. That's the main thing. So from that we can directly tell this A's velocity would be tangential to this OA. From that we can directly calculate what's the velocity of BA. So that's the main thing. So we have found that. So the next thing is how to find that second velocity direction or velocity with magnitude and direction. So here we have already found the velocity direction as well as the magnitude. So it's enough to have another velocity direction only. For the instantaneous, for using the instantaneous center method, we need to have 2 points. In one point we need to have the velocity with that direction and the magnitude. In the other point we need to have only velocity's direction. It's enough to have those 2 points. So when we are considering this, actually we knew that in this B it's going to move in horizontal. That's the main thing. Why is that? As they are bounded to move, we can directly tell this B is going to move either in this way or this way. So it's not a big deal. So we can directly tell that because it can only move along the horizontal axis. Degree of freedom is horizontal. So from that we can directly tell it's going to move either in this direction or this direction, which means the velocity will be in this direction, horizontal. So from that we have found the velocity, direction and the magnitude of this A point as well as the direction either this way or this way, the horizontal of the B point. So the next part is find the instantaneous center. For that we can tell we need to draw perpendicular line from this. So I'm going to draw like this. So first of all we need to check. I'm drawing, it's perpendicular, it's not perpendicular I think. Yes, we need to draw like this. Okay, so it's going to be perpendicular for this line. This means it's a straight line over here. So there are some mistakes. Okay, yes, I have drawn that. So after that we need to draw a perpendicular line from this. As it's in the horizontal direction, the perpendicular line would be in the vertical direction. So we have found the value, the instantaneous center of rotation. This would be the I. So this is not the question. They have asked to find what's the velocity of B. As we all know, we are going to use the simple equation B is equals to R omega. From this instantaneous center, we can directly tell this BA would be AI into omega. So this is the main point you should know. Why are we telling like this? From an instantaneous center, it's like a rotational motion. If I take this particular point, it would be having a circular motion. If we take a point from this B, it's going to have a circular motion. Think like that. So from that, we knew the value for A, BA. We need to find this by substituting this R into omega OA. And AI, we need to calculate the value for AI. That's the important part. However, you can use the basic geometries to find that. It's not a difficult part, but the calculations are a little bit complex to find that. So we knew the value of this angle 30, and OA is given as 50 millimeter, and AB is given as 200 millimeter. Here we need to find the value of AI. So how are we going to find this? So how to do that? So I knew the value for these two sides. From that, what we can do is we can find this angle using sine rule. We can directly find this angle if we use the sine rule for this triangle, as this is AB over sine 30 would be equal to OA over this angle sine theta. From that you can find this value theta. I think we don't need to find that. Yes, you can find that. From that, what you can do is you can find this length using OA cos 30, as well as this would be AB cos this theta. So there are many other ways you can use cosine rules also, but I think it would be easy if you use sine rule. It's okay. If you knew any other methods, it would be easy. If it's easy for you, just follow that. So from that we can find this OA. So if we knew the value for this, OB, we can directly tell this would be OB over cos 30. So this length. But here we need to find the value of AI, so we need to deduct OA from this. So from that we can find the value of AI. This would be a little bit difficult part in this calculation. However, from that you can find the omega. This is the first question. After that, we need to find the velocity of B. How to find that? Yes, that's a simple way. You need to have this, use the same equation. VB is equals to IB, the length from this, the perpendicular length, and IB into omega. We have already found the value of omega. Just note that the omega is the angular velocity of this rod. If you consider in any points at the 30 degree, the omega would be same. That's just remember this. If you take that omega from this point or any point, any other point, the omega would be omega would be the same at the theta at 30. So from that we can find this BB. For that we need to find the value of IB. It's not difficult because we can find the AI. From that we can find the IB also directly. After that we need to find what's the velocity of AG. That's the third question. So how we are going to find that? As we all know, this would be 70 millimeter. Also for that, the thing is we need to know what's the distance from this. So we need to find what's the distance of IG. How are we going to find that? This would be 70. As we all know, we can find the value of this. So if we know the value of IG, we can directly tell IG into omega would be equals to that. So for that, we can use, we know this value AI and this value is 70, and we can find the angle of this because we knew the value for this. So we can find this angle. From that, we can use cosine rule and find this IG. Or any other method. You can use either sine method or cosine method, but you can easily find that. So this is a method. So the main thing is how we, in this question we have learned how to use instantaneous center method to find the velocity of a moving body. In other terms, we can tell the velocity of all points in a moving body. The basic requirement to use the instantaneous method is at least you need to know 2 points velocity at one point you need to know what's the velocity direction and the magnitude. In the other point, it's enough to know what's the direction of that point, velocities. So I hope this video will be useful for you. If you have any doubts, just comment it below. I'm trying to give you the fastest reply. Thank you.